Global warming is now large enough that we can ascribe, with a high degree of confidence, a cause and effect relationship to the greenhouse effect.
In 1953, Popular Mechanics reported that Dr. Gilbert Plass had studied the radiant properties of atmospheric gases and predicted global warming from CO2 pollution. Dr. Plass was recruited by the U.S. military to study heat radiation in the atmosphere and help develop a new generation of heat-seeking missiles. These deadly weapons are working proof of how well we understand the behavior of greenhouse gases.
The U.S. Air Force needed to understand the atmosphere for communications and to design heat-seeking missiles. At certain wavelengths, carbon dioxide and water vapor block radiation. So the new missiles couldn't see very far if they used a wavelength that CO2 absorbs. Research at the Air Force Geophysics Laboratory in Hanscom, Massachusetts, produced an immense database with careful measurements of atmospheric gases. Further research by others applied and extended those discoveries, clearly showing the heat-trapping influence of CO2.
Between me and the camera is a volume that we will fill with CO2 gas. And as we turn on the gas, my image will slowly fade.
Because the ordinary air in the tube, composed mainly of nitrogen and oxygen, does not block infrared radiation, the camera sees the heat coming off the scientist's face clearly. But when the tube is filled with CO2, or any greenhouse gas, their molecules absorb the heat radiating off his face, blocking its path. As less and less heat reaches the camera, the image fades. If the scientist were surrounded on all sides by CO2, then the effect would be for him to get warmer, like the Earth in space.
That's exactly how carbon dioxide works in the atmosphere. It traps heat, preventing it from escaping into space, and warms the atmosphere in the process.
This is the glow of the planet sending that energy back to space in infrared. And as you look across, you'll see some high spots, and then you'll see some divots there. Okay, those divots are the greenhouse gases. The greenhouse effect is observed fact. It's physics, and it's physics been known for a very long time.
In 1859, the English physicist John Tyndall, using equipment of his own design, showed that certain gases in the atmosphere blocked and absorbed long-wave or heat radiation. 4 decades later, Svante Arrhenius, with thousands of manual calculations, made an estimate of the global warming power of CO2 that was very close to today's best models. In the 1950s, American Charles Keeling began to measure accurately the steady increase of CO2 in the atmosphere. Spectrographic analysis soon showed that the new carbon was, without a doubt, man-made.
The CO2 released by burning fossil fuels like oil, coal, and gas has a different chemical signature than CO2 released by living animals and plants. And the spectrometer shows that the increase in CO2 comes from burning all of those fossil fuels.
Okay, is it our CO2? Yeah. How do we know? 3 things. First of all, just do the bookkeeping. We've got a pretty good idea how much stuff we're burning. We see that CO2 in the air moving into the oceans. Okay, good match. Could it be anything else? All right, our friends of mine, Sue Brantley, Don Voight, used to go out and measure the CO2 coming out of volcanoes. CO2 from volcanoes is between 1% and 2% of the human source. Are Sue and Don wrong by a factor of 100? No. How do I know that aside from knowing Sue and Don? Well, there are tracers that tell us that. You can tell from the 14 to 12 carbon ratio and the 13 to 12 carbon ratio that the rise in CO2 is coming from something that was alive but has been dead a long time. You can tell from the drop in oxygen in the atmosphere that it's coming from burning for something. If you try to make CO2 by melting rocks to feed a volcano, it doesn't use oxygen. If you try to make CO2 by burning something, it uses oxygen. So there's a prediction. If it's a volcano, no change in oxygen. If it's burning, oxygen should be dropping. What is oxygen doing? Dropping. We can pound on the table. There's really nothing serious to discuss about this. CO2 is rising primarily from our burning of fossil fuels.
We can measure accurately the incoming radiant energy from the sun, and we know how much energy the Earth is radiating out as heat, and how much of that is absorbed and trapped by greenhouse gases. This study compared satellite measurements of outgoing long-wave radiation over almost 3 decades. After correcting for increased temperatures and humidity, this graph shows the change in outgoing radiation due to greenhouse gases between 1970 and 1997. The wavelengths for greenhouse gases show increased absorption, and the study concluded our results provide direct experimental evidence for a significant increase in the Earth's greenhouse effect that is consistent with concerns over radiative forcing of climate. If less energy is getting out, more energy must be coming back to warm the planet, and scientists have measured this as well. In this study, data from 3,200 ground stations collected over 25 years showed increased downward long-wave radiation as predicted by atmospheric physics.
So the key quantity is Earth's energy imbalance. Is there more energy coming in than going out? If so, more warming is in the pipeline. It will occur without adding any more greenhouse gases. The total energy imbalance now is about 0.6 of a watt per square meter. That may not sound like much, but when added up over the whole world, it's enormous. It's about 20 times greater than the rate of energy use by all of humanity. It's equivalent to exploding 400,000 Hiroshima atomic bombs per day, 365 days per year. The measured energy imbalance occurred during the deepest solar minimum in the record, when the sun's energy reaching Earth was least. Yet there was more energy coming in than going out. This shows that the effect of the sun's variations on climate is overwhelmed by the increasing greenhouse gases, mainly from burning fossil fuels.
Scientists have also looked at other potential causes of warming or forcings in the system. Accurate measurements are available of solar irradiance, which has been flat since the 1950s. We've also measured the effects from the ocean, like El Niño, and the influence of volcanic eruptions. When scientists put all these forcings together, they can make an estimate of the effects on climate over time. Using what we know about climate forcings, scientists have checked to see if they can recreate known temperature conditions of the past. This series of multiple climate model recreations over the last 120 years tracks accurately with the known temperature record over that time, proving that our models are realistic. But more important than temperature readings or climate models are the ways the Earth itself is showing us the indications of climate change. In this famous study by NASA researchers, the available data was gathered together. All over the planet, physical systems and living things are showing us a trend. The seasons when birds migrate, the blooming of flowers and plants, the migration and mating of fish and animals, the peak flow dates of glacial streams, the days when ice breaks on frozen rivers and lakes, the onset of winter and spring. Altogether, this study looked at more than 29,000 sets of physical and biological data. Of those, almost 90% were changing in a direction consistent with global warming. If temperatures are rising, then ocean water should be expanding and sea level should rise. And we do see that rise. The change is evident to farmers and gardeners as growing seasons and hardiness zones for plants have moved steadily northward over several decades. As more snow melts in northern regions, the outflow of Arctic rivers to the ocean has increased. Northern polar sea ice has been in steady decline over the last 3 decades. The great ice sheets of Antarctica and Greenland are losing more mass than anyone would have predicted just a few years ago. Glaciers all over the planet are melting and shrinking at increasing rates. Boots-on-the-ground observations from both American and international teams have shown the same long-term decline, now extending over many decades. With more moisture in the atmosphere due to warming, precipitation events are getting more extreme, both in northern and tropical areas. The evidence is clear, overwhelming, from multiple lines of evidence, and consistent worldwide, as demonstrated in 150 years of scientific research.